Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P154A indicates a battery sensor internal failure, specifically for the 2015 to 2020 Honda Fit. This code relates to the battery monitoring system, particularly the 12-volt battery sensor, which plays a crucial role in assessing the battery's voltage and providing vital data to the vehicle control module, PCM. The PCM uses this information to ensure optimal performance of various electronic components and systems in the vehicle. It's imperative to understand that this failure can lead to incorrect battery readings, potentially causing issues with vehicle startup and electronic system functionality. Identifying and addressing this error is critical for maintaining vehicle reliability, ensuring that all systems function smoothly without interruption. This guide will help you troubleshoot the issue based on the diagnostic info provided. DTC P154A points to an internal failure of the battery sensor. The main component affected is the 12-volt battery sensor, which monitors the battery's voltage and communicates that information to the powertrain control module, PCM. This sensor is typically located near the vehicle's battery, connected via wiring harness to both the battery and the PCM. Its role is essential, as it aids in ensuring that all electrical systems receive accurate voltage readings, which is crucial for proper vehicle operations. When this sensor is malfunctioning, it could hinder the vehicle's ability to start or lead to erratic behavior of electronic features, thereby affecting overall functionality. An effective troubleshooting process is necessary to rectify the underlying issues that may be causing this DTC. Several factors could contribute to DTC P154A being triggered. The most direct cause is an internal failure within the battery sensor itself, which makes it incapable of sending accurate readings. Additionally, poor electrical connections at various points, particularly at the 12-volt battery sensor and the powertrain control module, PCM, can lead to unreliable signals being sent to the vehicle's electronic systems. Loose terminals, particularly those connected to the battery sensor, can create sporadic contact, leading to failures that could come and go. Lastly, a damaged wire could also cause interruptions in communication. Being thorough in the inspection of these components and connections is crucial for effective troubleshooting and repairs. When experiencing DTC P154A, a variety of symptoms can manifest that indicate trouble. One of the most noticeable symptoms is erratic behavior of electrical functions. This can include flickering lights, intermittent operation of the radio, or other dashboard indicators. A more severe manifestation of this sensor's failure could be a complete failure to start. In some cases, the vehicle may start but fail shortly thereafter due to insufficient voltage readings, which can prevent the ignition system from operating correctly. Warning lights on the dashboard, particularly those related to the battery or charging system, may also illuminate to signal that something is amiss. Addressing these symptoms promptly can help prevent further electrical problems and improve overall vehicle function. The first troubleshooting step involves initial problem verification to confirm the DTC P154A. Begin by turning the vehicle to the on mode without starting the engine. Following this, clear the DTC using the Honda Diagnostic System, HDS. This clearing process resets the computer and removes any logged fault codes, enabling you to start fresh. After clearing, wait approximately 5 seconds before proceeding to check for any pending or confirmed DTCs once again using the HDS. If DTC P154A is indicated, it means the problem is persisting and you should proceed to the next step in the troubleshooting process. However, if the DTC does not appear, it may indicate an intermittent failure in the system. In that case, it's essential to inspect for poor connections or loose terminals, specifically at the 12-volt battery sensor and the PCM. Taking these steps helps narrow down the source of the error and sets the stage for addressing the underlying issue. The second troubleshooting step is critical for determining the failure area. First, ensure the vehicle is turned off and in the lock mode to safely perform electrical diagnostics. Then, disconnect the 12-volt battery sensor 3P connector. This is a 3-terminal connector that provides an interface between the battery sensor and the vehicle's electrical system. Once disconnected, you will need to measure the voltage between test points at this connector. Test point 1 is connected to the 12-volt battery sensor connector number 1, and test point 2 is the body ground. With the vehicle off, if you find battery voltage at this connection, it indicates that the battery is supplying power, but there's an issue with the sensor itself. Therefore, if voltage is present, the next action would be to replace the 12-volt battery sensor. Conversely, if there is no battery voltage detected, you will need to proceed to the next troubleshooting step to further diagnose the issue. In the third troubleshooting step, you'll want to perform a fuse check to ensure that the circuit is intact. Begin by turning the vehicle to the off mode again to safely evaluate the electrical components. Next, locate and check fuse number B15, which is a 7.5 amp fuse located within the underhood fuse/relay box. Ensure this fuse is functioning correctly. If it is blown or damaged, it will need to be replaced. If the fuse is okay, you should then repair any opens in the +B battery sensor wire, which connects between the 12-volt battery sensor and the B15 fuse. In cases where the fuse is defective, you would also need to check for any shorts in the same wire. By thoroughly examining this fuse and associated wiring, you increase the likelihood of resolving the DTC P154A and restoring proper battery function. After all necessary repairs have been made, it's crucial to conduct a final verification. Start by checking for DTCs again using the Honda Diagnostic System, HDS. This will confirm whether the DTC P154A has been successfully cleared. Once you've ensured that no related DTCs are present, it is also pertinent to check the overall functionality of the electronic systems dependent on the battery sensor. This could include testing the battery performance under operating conditions to ensure the vehicle starts without issue and all systems function as intended. Additionally, monitor for any warning indicators on the dashboard that might signify ongoing problems. Only after you've confirmed that all systems are operating smoothly can you be assured that the issue has been resolved properly and the vehicle is safe for continued use. To prevent future occurrences of DTC P154A, it's essential to engage in regular preventive maintenance practices for your Honda Fit. First, conduct regular checks on the battery's condition, monitoring its voltage and overall performance to ensure it is operating efficiently. Inspect all connections leading to the battery sensor periodically to avoid issues with loose or corroded terminals, which can lead to unreliable readings. Keeping connections clean and free from corrosion will also minimize the risk of intermittent failures. Additionally, performing scheduled maintenance as per the vehicle owner's manual will aid in keeping the systems functioning correctly. Regular maintenance not only extends the life of the battery and its sensors, but also ensures that you remain aware of any potential issues before they escalate into major problems. In conclusion, addressing DTC P154A requires a thorough understanding of the 12-volt battery sensor and its integral role in vehicle performance. Systematic troubleshooting is vital, starting from verifying the problem, followed by identifying possible failures, and lastly, performing appropriate repairs. Ensuring that connections are secure and components are functioning correctly can significantly enhance vehicle reliability. Routine preventive maintenance is essential in avoiding future issues related to the battery and its sensor. By adhering to these guidelines, you can ensure that your Honda Fit remains in optimal working condition, providing a dependable driving experience while avoiding the complications associated with battery sensor failures. Please like and subscribe to the channel. See you next time.